Okay guys, so we're back on another video, and this video is about physics, and today we'll be learning the most important thing there is in physics, I guess, which is the vector. And I tell you it's important because it is related to the things in this world very closely. So let's start with the basic concept of vector. So in our world, what we do is we measure most of the time. We quantify things. We quantify some stuffs. So in the quantification of this stuff, I'm using a lot of grammar here, so just mind me. So in the quantification of the stuffs, there are two different quantities. The first one is a vector quantity, and the second one is a scalar quantity. So from the word vector and scalar, what do we mean? So let's just say the word scalar. So it has the word scale in it, right? So it only measures, okay, only the measurement, or what we call in science terms is magnitude, only the magnitude, and there will be no directions involved whatsoever. But in case of vector, there will be a magnitude, of course, and there will be a direction. Now it may seem very unlikely to visualize these two things, but we'll get to that in a while in the visualization. So what I would like to do is I would like to go on a journey with you guys. So let's say our journey starts from somewhere around here in this page. So let's say that's the point A. And let's say we go straight down A and reach a point B. Okay? Then again, we go from that point to this point, which is, let's say, C. And again, we roam around. Let's say in a curvature, we roamed around for a while. And then we reached a point, which is point D. Now, we will quantify our walking or our journey in two things now. The first quantification can be done using vector, okay? And the second quantification, it can be done using scalar. So let's just go with the scalar first. So you can question me on our way to D that, yo, Faisal, so how far are we from A? So what distance did we cross to come all the way to D? And I would answer you, just say A to B, it took us X meters. From B to C, it took us, let's say, Y meters. And from C to all the way to D, let's say, it took us Z meters. So I would tell you that the scalar quantity of it, that is the distance that we crossed, will be X plus Y plus Z meters. So we will cross these whole distance, right? We'll cross X plus Y plus Z meters, and that is completely true. So in your Apple Watch or so, you'll see the steps that it measures how much you have walked. So that's in distance. But you can also say, what's our position from A? So how far are we from A? And to answer that, we have to draw this particular line from A to B. This is a straight line from A to D. So that will be our displacement. And by the word displacement, you already know that it's the placement there where we displaced. So we're at point A, now we're at point D. So how far are we from our initial point is the displacement. And let's say I could have said that you know, This is, let's say, 5 meters. So we are from 5 meters from A. Now you can also think that 5 meters. Okay, so I guess 5 meters in that direction we can find A. Also 5 meters from this direction we can also find A. 5 meters from this direction we can also find A, and so on in infinite amount of directions we can find A. So that's not a way to justify or to denote A or to denote the displacement. We have to say the directions with it. So let's say at point D there is a graph, or there is a compass. We have a compass at point D. So I would say that it is north and it is west. So we're at around 60 degrees northwest. So from 60 degrees northwest we have A on 5 meters. So that's how we justify vector quantity and scalar quantity. So the vector quantity here will be completely different, and it will not be called distance, it will be called displacement, because alongside with the magnitude we also justified the point A with a angle or with a direction. So magnitude was used and direction was used. So the displacement here that we did, the displacement, it is a vector quantity, and the distance, it is a scalar quantity. And there are also different examples of vector quantity and scalar quantity. Let's per se mass. So we don't need anything to determine mass, right? So I can just clearly say I am, let's say, 79 kilograms. So do you need any directions here? Do I need to say I'm 75 kilograms north? No, we don't need the direction here. It is completely irrelevant to our topic. So this will of course be a scalar quantity. Okay. So what about time? What about time? So time, let's say 5 minutes. So it takes me 5 minutes to get ready. Does it take me 5 minutes to get ready south? Of course not. We cannot use any direction here, so time is also a scalar quantity. And we also knew that direction here, we already discussed this right now. Sorry, the displacement here. The displacement will be a vector quantity because we need a direction here. So the clear concept that we all need to know is, if we need a direction, it will always be a vector quantity, and if we don't need a direction, it will always be a scalar quantity.